The special bearing is going to be your try it yourself. When I looked at the remaining two with the crown and then the ribs and not really a revolve, this one has some interesting geometry in it, and this one is a little more complicated than I want to throw at you. So we're going to analyze this. We'll put a pause in. I want you to attempt making the model yourself and then come back and watch the video. So things that jump out at me, you're at 1.436 to 1438. 1436 is your maximum material condition for the through bore. So we'll have the same type of axis of revolution. Another thing to watch out for is there is this little relief, right? So that little notch can either be included in the revolve, or you could build it out separately. I have a technique for including it in the revolve that works pretty good. The 0.375, I'm not happy with that call out. If you want to use the hole wizard, we're gonna analyze that one a little bit more. So I will put a note in the assignment description on the A5 page that this is just going to be a 5/16 flathead standard hole wizard geometry. So you should see a through hole of what did we just have back here? 3.4, 3.75. The countersink will be 82 degrees. Let's see, it should be 90 degrees. No, 82 degrees. Get my metric and my standard mixed up. So it'll be around 0.75 by 82 degrees, but we're not gonna worry. Whatever the default is, that's gonna be fine. As far as the rest of the geometry, pretty straightforward. 512, 476. I don't see anything in there that's real critical. I guess the notch depth is 1/8 of an inch. Comes up flush to that outer wall, and it's 200 thousandths wide. So let's go ahead and pause and come back after you've attempted it, and we'll run through the steps. Okay, so let's see how you did. The overall geometry, kind of the same as what we've been doing for the last three models. So let's start with our standard center line. I'm looking at this geometry in the top plane. We could draw this geometry in the right plane, but the intersection of the countersink is kind of confusing. So I want to keep the geometry as simple as possible. So we'll fly that out. And this is in inches. So file new, part inch. Opening up the sketch in the top plane. And actually, I've done the previous three in the top plane. Now I'm going to stay with that one. I say we're going to do one of these in a different plane just to have the contrast. But since you just did this one yourself, I don't want to make it more confusing. So top plane, center line, vertical, infinite length. Place it on the origin. I want the base of the piece to align with the origin, so I'm into my line command. I go this way, and down, and over, and down. So usually you'll see me sketch all the way around. It's kind of a habit, or it's become a habit. It is not a requirement. I would like to have the through hole included, so I can get started with that. So we said our maximum material condition puts us at 1.436. And since I'm thinking about it this time, we're going to go ahead and put the limit dimension on. And it has a plus 2 thousandths to get it to 1.438. And then if I look down through here, critical dimension, we're already a diameter. Nothing really in these two find that mark for drawing. So right click, mark for drawing. Okay, so the outside is 2-inch 60 thousandths. So making sure I'm on the opposite side of the center line, 2.06. The outer is 0.512. All right, so okay, it would help to move that decimal place. 5.12. What do we have for a depth? Well, we have an overall of 3 inches, so I can go from, well, it's still in diameter, so let's escape. I really don't want to be on the midpoint. I don't know that it's going to hurt anything, and I haven't generated anything at the top, so selecting the point will be okay here. And then I'm going to go back to my selection. We'll go back into the line command, come over, and close off. Back into the dimensions. Alright, so I see a dimension of 2 inches with a thickness of 0.62. Alright, and wall thickness, no. That was the 4.76. So we'll go back into the diameter, 4.76. Alright, so if you drew the notch, the line and the notch into the sketch, that's fine. I'm going to do pretty much the same thing, except I do want to introduce a tool that it comes in handy. So there's the notch. If you had just gone all the way around and left that segment open, that would be fine. I'm going to go ahead with the dimension, 0.2. Depth of 0.12. Alright, and then let's say this is a what-if scenario. I don't know if I want that notch in there or not. We have under our sketch tools a command called split into Tease. And what split into Tease does is when I pick on that line, it makes it 2 segments. So we'll go ahead and hit OK. Now I can move. I'm going to make it coincident with the endpoint, and then this segment is going to go to construction. And we're out a little ways, so it's not going to be apparent that it's construction or a center line, but it gives me that ability to where any relations that I might have lost by trimming it out or deleting it, I can retain those relations. I can retain the information, but I still have a separate entity. The other thing is, in my what-if scenario, if I were to window pick, oh, I need to go left to right this time, I just want those items, then I can switch for construction, and let's see, object, oh, I didn't get those. Alright, so I can take, maybe it's on the pop-up. I can switch those back to construction, and they won't participate in the revolve. So it gives you a chance to toggle, see if it's going to work, get a sense if it needs to be another feature or if it's going to be okay. And I selected too much there from left to right again. So I'm going to end up having to change the construction geometry back. But that pretty much gives me my profile. Alright, so when I bring this back in, we're looking at the shape, comes up and over, has a little notch, comes back and closes. Alright, so one center line, nope, I take that back. I put in a second center line as soon as I did this. Alright, so that means that I'm going to have to select my center line, revolve boss base, select the axis of revolution that we created at the center, and we're going to go 360 degrees. Alright, so that gives us the geometry. There's no fillets and rounds. Let's take a quick look at the notation. So cold rolled steel, if we wanted to put a material on it. We'll be putting material on our parts when we start the assembly so that we can get some engineering data out of it. The other FAO, finish all over. Call out would be that we want surface finish, that if there's anything raw, it would need to be cleaned up, sanded, scotch brighted, something to make the surface presentable. Alright, so said that the 0.375 call out. Let's go to Control 1. And we'll set up the conditions for the hole wizard. So I've selected the face. I'm hitting the S key. If you don't select the face and just hit the S key, and it'll let you go into hole wizard. But when we go to positions, it's going to say, do you want to go into a 3D sketch? And no, we do not want to go into a 3D sketch. So when you come over to positions, then we're going to end up selecting that face anyway. So I think it's easier just to go ahead and pre-select the face when you go into the command. All right, so whatever I changed last time, reset the custom sizing values back. We have an ANSI inch. We're going to do 82 degrees. Socket, countersunk head, cap screw. Well, we're going to do a flathead screw. I'm going to have to go back and look at that one. I don't recognize its geometry. So we said that the fit, we can allow it to remain loose. We're at 34, 37, 635, and 82 degrees. All right. If I need to, I can put 0.375, diameter 0.75, and 70 degrees in there. And without knowing what fastener or what geometry is going in there, I'm going to stay with standard until I get some clarification on that one. All right, so I picked the face. Now it's allowing me to position the first hole. And I hit that right mouse button at just the right time, and it kicked me out. So my choices are to right-click on the feature and edit the feature, or, as long as I don't get too crazy, I can edit the sketch, the first sketch in the list, and that's going to take me into make the modifications, drill my base circle, switch it to for construction, and go smart dimension for the base circle is 3 inch 120. Alright, so previously we've done a couple of circular patterns. So if I go without the circular pattern, we're going to go vertical. And we've done a few of the angular dimensions in the extrusions. But there is another way to set up an angular dimension. All right, so I'm going to place the 2 points on the base circle. They shouldn't move away. They'll be able to orbit with it, but not leave the base circle. And when I go into Smart Dimension, my choices would be to add a center line to each of the points, and that works just fine. We have a dimension type that says I can pick the vertex and where one leg would be, and then the opposite leg, and that will also give me an angular dimension, so 120 degrees. So vertex first and second. Now if you pick those in the wrong order, then it's going to look strange. We're going to yeah, I'm not sure how that's going to look. I just always pick your vertex first. All right, so that gives me the 120 degrees, 360 divided by 3, and the locations, and we go ahead and accept it. We have our geometry. So I think this is the one that I want to go ahead and take into the drawing. So I'm going to go ahead with the save, and 7.9 special bearing. And we're going to open up a new drawing. All right, we haven't created any custom templates yet. After this lecture, we'll have a little bit of time. We'll do a template, and then a real quick introduction to some of the cam operations since I've been talking about manufacturing. And let's go ahead and stay with the ANSI A landscape. All right, when that comes up, by default we have the model view. If you uncheck the start command, then you'll be picking either the view palette or coming back over to the view layout and picking your model view manually. So for now we're going to leave that checked. I'm going to hit the next arrow, and I want two views and the isometric. So the front, the right, and actually I think I'd rather have a section view, so we'll do the front, we'll uncheck the right, and we'll leave the isometric. So that gives me my two views. Center lines are set to on, so that will put in for the center marks. There isn't really a base circle command or geometry in yet, so let's add the section view. I'm going to bring it over until it snaps to the origin or to the center of the wheel. We're not doing any strange jogs or geometry, but if for some reason we needed to, I could bring this line around and send it through the other countersink if that was useful information, and that would be over here on the aligned. So we'll go ahead and accept and place. All right, we'll bring that down a little bit. That seems like it's a little too big for the reference. So I'm going to use a custom scale. We'll go from 1/2 to 1/5. Let's see. Then for our geometry, we'll be in the annotation, smart dimension. Okay, so our outside diameters. Oh, the mark for drawing. Let's see how that works out. So model items, and by default, marked for drawing is the only one checked, and then the next one over is not marked for drawing. So between the two of them, that pretty much covers everything. So if I haven't marked it for drawing, it won't come in on this first pass. If I need all of the dimensions to come in, then I just click the second box. Whole wizard profiles, no. Don't really want the whole wizard locations. I didn't do a pattern. Tolerance dimensions, well, that one might do it instead of the marked for drawing. So let's go ahead and accept. Entire model, and it brought in the 144. Okay, so that being the case, I don't like where the extension lines landed, so I'm going to grab the grip, grab a little handle at the end, bring it out, and then we're not enough decimal places. So over on the property manager under the dimension, we're going to go up to 3 decimal places, and that will set the dimension for the bore. You can give it a little bit of room. Okay, so that was the through hole. That one takes care of that. I'm going to move section A, well, somewhere where it's not quite as in the way. We'll go from line to line, edge to edge, 3 inches. Outside edge, 2 inches. And something that I can't measure is not typically my favorite to dimension to, even though we know that web is 0.62. My preferred dimension would be something that I can actually physically measure. Right, so whether I take a depth mic or calipers and go from the edge to the face, that gives me a much better sense of what the geometry actually needs to be. And then for the depth, kind of the same thing. 0.12 off the face is going to be hard to get the calipers, get a depth mic in. Whereas if I go from the top edge to the depth of the groove, that gives me a linear distance, much easier to measure. Don't know about the 200 yet. I could take a gauge pen, as either that is on the turning if I have a grooving tool with enough relief to go in and open that up. Otherwise, I might have to set it up on a mill with a extended length 3/16 end mill and interpolate around the outside edge. Otherwise, blending is pretty much the only critical issue there. Let's see, for our hole call out, we have the 3 holes. When I pick one, it's going to pick up the geometry, and it tells me that there are 3 times the 0.34 through 64 by 82 degrees. If I want to adjust those, then the through hole diameter is the current selection. We're going to make it, we're going to leave it on its tolerance, but I'm going to switch it to 3 decimal places. The 0.64 by 82 degrees is fine. I just want to find a spot to where it's not too cluttered up. Let's go ahead and select. And we'll put the isometric up in the corner a little bit more. Alright, so since I didn't get a base circle, I could go ahead and give this linear dimensions. Alright, and so those 2, and it's referring back to the model that is basically in conflict with another relation. And if I go that way, that would give me enough information for locating, since those 2 holes will be symmetrical, to be able to find those dimensions and put them in position. Since that's mounting something to something, probably would want those to be, even if everything else is in 2 decimal places, those 3 I would want to be in 3 decimal places just to hold the positional tolerance a little bit tighter. Okay, so that's looking pretty good. The other thing that we can do is the sketch is available to put in a circle, and I can do the same base circle construction, tell it that it is for construction, and go ahead and accept. And then when I put the dimension on it, it tells me that it is going to be a driven dimension. And in effect, these numbers, since they're there, have a higher priority. Then I will go ahead and apply parentheses, which says the 312 is just for reference. Alright, so for a first pass, we got most everything. We have enough to manufacture from. It needs to be probably needs to be redlined and reviewed, but for the most part, we've got enough information to get started.